Testing 1, 2. Right, let's see. I think I figured out what it is while trying to fall asleep, basically. And then I forgot it again, of course. I think this thing here, basically, you know, this is this thing here. Also, this thing, as this is a base class, but also this one as a virtual base class. And lo and behold, that one is the other one that has this as a base class. And it also has that shadow state bridge as a base class, as a virtual base class. And I think the solution was simply that I have to get rid of this and replace it with that. Yeah. Right. Mohammed, hello. No, I don't think I can explain it because it's way too difficult. Way too difficult. I'm just working, that's it. Grab project sources for this thing because I want to delete it. I think I can delete it. Before I start to delete everything, maybe I should have a good look at where it is being used, like here. Virtual is used in. Okay, it's been returned by. No, that's not the one. Being passed here. Also less interesting, I guess. Is used in is just taking it. Yeah, I think that the. It's only being passed. Wait a minute. Okay, this is include. Here's the derive from. Another include. Another derive from. And here is an in used in, which takes it as an argument, right? That's what we were talking about. A chain of variable declaration, yes. And since it's a virtual function, all the others are either. Well, this is the virtual one, the rest are overrides. They all take the same argument. And then there is one line left here. No, it's not. All of them. Yeah. Okay. Let's get rid of it. Getting rid of it then means that I can simply remove this whole file. Wait. Well, the include anyway. And also the base class. Man, what a cleanup. Was that one, line 5. This whole file can be removed. Let's use it with get from the pipeline directory. Fill that thing. Add shadow variable declaration.h. Hello, Frownside and Gums. Yeah, I should show you, right? If you're really interested in stuff. Let me remove this quickly. No, can I? Yeah, I think I can. No, well, let's wait. Okay. Wait. If I run my tests, then I get this crash. Still editor open. I get a crash here saying that while trying to find a certain string in a certain object, it couldn't find it. And yesterday during the stream I figured out that the reason for that is that it is adding it to the wrong instance. And the fact that it is the wrong instance is because I just do a cast of, I think I made a readme that maybe, I mean, probably not, but if anything clarifies it, and that would be it. Oh, I'm not sure if I made it. Well, definitely not here. Oh no, wait, it was on here. I have this inheritance structure. So we have an add shader stage which is derived from this object. And I have a add push constant which is derived from that object. And then add shader stage is used as a virtual base class for both add vertex shader and add fragment shader. And then the final user class is simply derived from, let's say, add vertex shader and also from add push constant. And I thought with my stupid head that I could cast the add shader variable declaration instance of the add shader stage to a push constant, which is not true, because there are different instances in the inheritance tree. So now I'm getting rid of it, and I'm going to replace what I was doing using this. I'm going to use that, because that is virtual. Then there is only one instance, and then the cast will work. So that's what I'm doing. It'll take forever to really explain it if you're not already a C++ guru. Well, at least familiar with multiple inheritance of virtual classes, aka the diamond structure, also known as. So I was going to remove this. I am in pipeline, and just want to get rid of this thing. Git remove that thing. I don't have a .cxx. Let me go back here. Did I edit this on already? I think so. And this also 36. Then we get number 4. Okay, begun. And 20, which is now become 19. I have to delete this. Is it a grab project sources again? So now only declarations of is used in are left over. So I can edit all of them. And then I'll just replace the add shader variable declaration with But the other thing, which I forgot. The other thing is this one, right? Add shader stage. Add shader stage bridge. It is also defined in pipeline. Yeah, well, add shader stage bridge. Yeah, also in pipeline. So I can just do substitute that with add a shader stage bridge. Yeah, I also want to change the name of the variable actually, so add shader stage bridge. I don't like the name, but okay. Next, why is this include still here? So, got rid of all the includes. Might as well do the other one, right? So substitute that with add shader stage bridge. Next, replace that and the other one as well. Next. Yeah, and then I have to do the last thing here as well, I guess. And here again. It should work. Here's the static cost, by the way. So now the add shader stage bridge is a virtual base class of add push constant. Therefore, now the static cost will work because now it's just a virtual base class plus instead of a normal base class. Let me then highlight. Next. Redo. Search. Redo. Next. Replace that and then replace that one. Replace that. Replace that. Oh, wrong key. And it's gone. That's how to compile it. I think I didn't include a header for it. I removed headers, but didn't re-add headers back. It's not been declared, rule declaration is used. Pipeline. Yeah, okay. It does have its own header. So everywhere where I removed headers, I'll have to add it again. And this is in shader builder, so okay, I'm just including the pipeline directory. I'll just Wait for the compile errors, I think, to see what the includes are missing. That's funny. Oh, I do need an include. Damn it, you know, I press Shift 3 for the hashtag, and then I let go of the Shift and I press an I, and I still get a capital I because the Shift key is slow when I let it go. And that happens so often with this keyboard that it's super annoying. Debug.h. What? I said now it's going to work, but it doesn't. Cannot convert from pointer to base class add shader stage bridge to pointer to derived class Vulkan pipeline add push constant because the base is virtual. Disappointed in C++. Okay, so that still doesn't work then. Did I need a pointer or a const pointer? Auto, yeah, of course. What else? No, wait. Convert, this one's non-const. I guess it is non-constant. Now add push constant is part of pipeline. We are in pipeline, so that should work. This is, however, a accessor. No, well, yeah, well, not really. I got a virtual, and kind of the same thing here. Don't call it when it is not implemented. And it's going to be implemented by, well, by the push constant, I guess. So copy this, jump to push constant, and I can implement it. I can delete that. Push constant. Usually I put virtual functions a bit to the bottom, but I want to be private. It's very hard to decide where to put stuff. I'm just putting it here. Okay. Yeah, this can be deleted. Pretty much don't need that. That push constant does not name a type. Still have to add it. That is part of pipeline. Yep. Well, just make it like that, I suppose. Pipeline. Forward declaration. Invalid conversion from, oh, yeah, oops. This is a const pointer. If this is an accessor, so it was not a const. It was not really an accessor. If you return a non-const to this pointer, and it's still complaining about the same thing. Oh, because I forgot to change the yeah. This is a head of, sorry, an override. So I have to remove the const on the base class as well now. Cannot convert from pointer to base class. Oh, I have the same thing elsewhere. This converts to an add shader stage. Boys Bunny, I didn't stream for the whole day and I'm just streaming for the end of the evening. What is Fish Center anyway? What am I going to do here? Add shader stage. I guess we'll just need another accessor then. Convert to. This is madness. I'm pretty sure I already have the add shader stage. The moment I call this function, it's just a shader stage. Why would I not just pass that directly instead of the bridge? Okay, let's do that and then pray that it works. So instead of a bridge, I'm just going to do the shader stage directly. Underscore bridge. Don't need that. Don't have any others. And then of course we have to remove the bridge stuff also in the declaration of this file. which means here. And then on all the other places. TPS at shader stage bridge. Okay, I'm starting to feel doubtful again. Especially because this include. No, it's not include. Nonsense. This is the first is used in. Oh man. Okay, you should be able to do that in one go. I want to do it in like one go. No, that's dangerous. File wide find and replace. It's always a little bit dangerous. I'll just do it character by character instead. Like this. Or maybe like that. Stage bridge has been removed, I think. Yeah. And then the next file, and the next, and the next. I might as well do it like that. Yeah, this one is annoying. This one is definitely annoying here. Let's jump to that. And then we have the last file. And I want to jump to all the bridges. Let's burn them. Next. And then, next. And then, oh, this is the one with the include. Yeah, let's see. Why would I even need it? I don't need it. Can you do just fine with a forward declaration? At shader stage looks also much better, don't you think? Ah, here's our convert, but this convert still works because it's simply a virtual function of a virtual base class. It couldn't do a static cast, but this should be possible, I hope. Well, op hoop van zegen. No idea how to say that in English. Okay, Post Bunny's being funny again. Yeah. It doesn't compile. Invalid use of incomplete type class. Pipeline at shader stage. Declaration of Vulkan pipeline at shader stage pointer shadows a parameter. Okay, now it's just whining. No, it's not. I thought I deleted this. Was it a different function or something? And we are linking. And we now crash here. Which is a different assert. So I guess I fixed it. We crashed at a different point, therefore I must have fixed it. I've got a lot of nice assert text here also. Must alternate between characteristic range filled and characteristic range compiled. The current value of the mcontinue state is the state that should have ended with run state. Okay, definitely something I want to do in the debugger then. Run in DDB, so I can print that stuff while reading the text. Hey, LGL's back. Mario. I thought you were correcting me. Shadow is a parameter. Well, I had a function. I had a function argument with the same name as a local variable that I made. So then, from that point on, I would not have been able to access or use the function argument anymore. I think that's worth a warning. Okay, we must alternate between characteristic range fields and then compile. The current value of mCurrent state 13, that's not useful, is the state that should have ended with run state is expected state. Where expected state must be replaced with the little state of the value that it has. In expected state 10. Or mContinue state forgot to call setContinue state with the correct value. It's also mContinue state. Yeah, but which enums have the value 13 and 10? I guess I'm just going up. That looks like nothing we can use. Wait, this is in. No, actually you can use this. Let's list this from. Just go up. Go up to the top. And let's just print this value here, and that is in decimal, please. 12. Oh, okay. So now go down, list, fill is 10. Hello. 13. Oh, okay, that's 13. And then what is 10? Anyway, pipeline characteristic range fill. And it was saying here that that was 13, so that state should have ended with run state equals 10. Or this is so difficult, I need another tab to edit this file. Now we have the state. It should have ended with run state equals something. And we did. Print. Again. 9. Aha. Okay, that's so that should have been 10 and or we forgot to do something. So run state is must be expected state, or m continued state forgot to call set continuous state with the correct value. Well, we do call something. So one of these two is wrong, apparently. Now, as you look at, say, compile ends with set run state compiled. I think this code is actually good. So we do a compile, blah, 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 and then we are done. So now we have compiled, so we go to compiled. Yes. Likewise here we need to fill, so we do da 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 da, and then we go to filled. And the continuous state after filled is definitely compile. And the continuous state after compiling is again fill. It'll alternate between the two. So I don't think there's anything wrong here, which means that the debug code that is asserting is wrong. We get the same thing. After initialize, you do initialize, then we continue with fill. Characteristic range. This is derived from characteristic range. Characteristic range fill, characteristic range initialized. Compiled, yeah. I don't see a problem here. So let's have a look at the actual problem here then. Up, no, down. So the run state is, you'll never know, right? 11, okay. The expected state was 10. Yes. 9 compiled. It's 11. What? Continue or terminate. 8. Yeah. Twilight Zone Hall. What sits between filled and compiled? Pre-processed. Oh. Hmm. Processed. Oh, but it's in the fragment. I'm not using the fragment thing. Wait, is there another one? No, this is the only one. Oh, I'm so confused. What am I running in the first place then? And this is the blue thread, number 6. Compiling. I would say didn't miss one, right? It is running state vertex pipeline characteristic range compile. After that, it should run fill. Okay, so we do compile, build shader, preprocess 2, entering, generate, compile, compiling. And compiling takes a while, so now this thread is busy. Get all kinds of other threads doing stuff. Don't see an 06 here. Until here. And then it says SPV cache created a module, and then we core dump because something's wrong. None of this makes any sense. If that search will fail, then just print it out, I guess. It's fatal. Core dump. I can just use this state string implementation, I think. As is a virtual function. I hope. Yes, that is virtual function. So just what it says here. State what we got to call what goes here then? Can we note that here? Now we have the nice words with it. While running characteristic range compiled, state vertex pipeline characteristic range fill should have ended with the run state is characteristic range preprocessed. That's nonsense. But I think I looked at the wrong one, right? So I have to look at this one. Huh? Yeah, that's it. Phil forgot to run to set the continuous state to preprocessed. No, to preprocess. I skip preprocess. Or not. I don't even have this. Hey, you're so difficult. Okay, I still don't know. Yeah, preprocessed. This whole thing is a mess. I used the wrong namings, I think. Hey. So from the top of my head, I run initialize. During initialize, I do all the add stuff. So add. Then I run preprocess. And after preprocess, we run compile. So called a build share. So we should run this thing first, and then that, and then that. And after this, we must go back to the first state after initialize. So I must go back to fill. And the complexity here is that I'm using a base class, which tries to reduce user code duplication by doing certain stuff that is also always returning, but apparently not making it very easy to use. So we go to the base class by setting the run state to whatever the base class state is that we want to run, and then we do a break, which leaves this switch, which then calls multiplex implementation with that run state on the base class. So each state that I have here must end with run state is something followed by a break, which then calls the base class. State machine, or whatever you want to call it. That then, when it is done with whatever it wants to do, will continue the derived class, or this task, with whatever we set the continuous state to. So initialize must set it to fill, because that's the next one that we want to run here. And I tell the base class that we just initialized it. So initialized here. That's not wrong. I don't think this code is correct, but the base class is wrong since I added a new state. Or wrong, I don't know yet. Anyway, next we run fill. That's confusing, right? I have a fill and I have a preprocessed. The difference, man. Welcome back, Post Bunny. I have here fill. The whole fill is old. I should name it differently. If you see what it is doing here in this super simple first test case, that doesn't even work yet. It seems to be just doing a preprocess. So that's very confusing, right? If there is a preprocess, maybe I renamed fill to preprocess? Nah, I don't know. Anyway, if I forget the base class and I forget the naming, then this is the next thing that I want to do, which does preprocess. And I think that's pretty logical that then I set the next continuous state is the next one that I want, and I signal to the base class that we just did fill. And then we do the compile, which does the compile. And then the continue must be fill again. Yep, and we just compiled. So I don't see anything wrong here. But if now we go look at the base class, what that is doing, then maybe it becomes more clear. So yeah, let's jump to the base class. How do we do that? So this thing has a preprocessed between filled and compiled. Huh? What? Sure, I did that myself, like yesterday or 2 days ago. And I have no idea anymore what the difference is. Bad naming. Now what I want to do between preprocessed and compiled? I don't know. Anyway, this is the base class. This is where we assert. And well, initialized this works, I guess. Let's go straight to filled. So at some point we are filled. We did run the user state blah blah underscore fill, and then we run this, which just calls this function, characteristic range filled. And then I want to continue with continue or terminate. I just have to keep checking if we want to have to terminate or not. Now usually that's not true, of course, you can ignore that, not terminating anything yet. So set state m continue state. So even though we go to continue or terminate, in effect we just go continue with the continue state. And this whole thing is not doing anything else but a quick check if we have to terminate or not, and calling this callback, of course. Okay, anyway, we are here, so I set that state, and then the debug state says expected state is preprocessed. Ah, okay, so that's the problem then. It expects that after this continuous state we will do that, and we don't, we do that, so we skip this. That's the problem. So that's why it asserts. Wait until we're ready to start compiling. Okay, there was signals involved. So on the do fill signal, we continue with it's so confusing this. Forget initialized. On the do fill signal, we continue with we always continue with continue and terminate. And now you continue with whatever expected state is. No, we continue with what the continued state was set to. Okay, so after fill, you do filled, which waits for do preprocess. And I guess it should do preprocessing after when this signal occurs. And then after that we should do this, which then calls call back, does the continue or terminate again, and waits for the do compile signal. And then we get compiled, well then we're basically done. Nevertheless, we wait for the fill signal to continue at the top. Okay, it's kind of clear to me. We just have 3 states and we have to go like ding 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 ding. Text is wrong then. It's not alternating, but we must rotate between characteristic filled, characteristic ranged, pre-processed, and characteristic compiled. Would be nice if I could just print here the correct set continue state. But I have no idea what that would be then. Okay, the only way I'm gonna understand this again is by looking at who is sending the signals, I think. So we have a do preprocess and a do fill signal. And it seems to me that if I look at that maybe I get an idea of what is the difference. The do preprocess signal is being sent here. Okay, so this is the pipeline factory, which is also a task, as you can see. All that does is it begins with calling initialize. So we have a bunch of characteristics. So m characteristics is a container, and we run over all of the elements of that container, which is all of the characteristics. And then we run them, which calls the initialize state to be run. And then we wait for initialize. So when all the characteristics have been initialized, then it will continue with, well, initialized, which is here. And then it does some initialization of multi-loop stuff. Here's the inner body of the multi-loop. So multi-loop is a dynamic number of for loops inside each other. So you have for each characteristic you have a for loop. Since we can have any number of characteristics, we can have any number of for loops. And inside the inner loop then we have this body. And that calls do fill signal on all the characteristics. So after all the characteristics have been initialized, they run the do fill state. And then the pipeline factory is waiting until all the characteristics are done with filling. So this wait here waits for all the characteristics being filled. And now we continue here after they all have been filled. And then it does it does prepare shader resource declarations, which apparently can only be done after the fill. After all characteristics did the fill. If you ask me, fill is really preprocess. No, filled, sorry. We have to do... what? I'm so confused there. I guess fill is prep work before you can preprocess. It seems very illogical. Well, that is that are changing adds maybe. Strange. I don't know what I was thinking here. I don't think the pipeline factory is doing a lot of stuff, except that when we set, you call this before we do fill, set the fill index. So every characteristic gets its current for loop variable set. Fill index is another word for the loop variable that belongs to the characteristic range. So each characteristic range gets its current fill index set, and then it has to process that. Now, depending on wherever it is in its loop, it needs to do something. It can do something, and only when all of them are done, we run prepare shader resource declarations. And then we start to do pre-processing. So apparently prepare shader resource declarations must be done before we can start pre-processing. So I guess that the filling has to be done before we can do the prepare shader resource declaration. And then kind of obvious, I guess, that we have to do pre-processing before we can do compiling. But the strange thing is that it is waiting again for all the characteristic tasks to be finished with pre-processing before any starts to compile. I don't know why that would be needed. But yeah, then who am I? I don't know. It's all super unclear what is what needs what. Spread over many threads. I lost my overview, if I ever had it. I just know that I added the preprocess stage very recently. So not that long. Maybe I should just watch my old streams back. Where's this stored in? Pointer. Pipeline factoring. This is so weird. Okay, this is something that looked on. It's not mutex protected, so I guess it's being filled by the pipeline factory itself. I guess right here, and then I guess it cannot do that while characteristics are still pre-processing stuff. Anyway, let me add this to the calling code to make it a little bit more easier to understand there. Oops. And this is preprocess. Sorry, but this is preprocess. I think I have an empty fill here, something. We have to rotate, if the base class demands that we rotate over 3 states, then this class, the derived class, also must have 3 states. Is there no way to skip that? Let's assume that fill is empty, it just doesn't exist. Then continue state compile, yeah, run state filled. Well, I would have to run that because it's expecting me to call that. Okay, let's add a preprocess state. I don't know. Or is it? And that comes after the fill. Well, basically this is preprocess. So I'm just going to paste that in here. That other one, I don't have any other. Wait, yeah, it's the only file I have with this for this thing. So it expects us to do a fill, and our fill is just doing nothing. So I can now do fill index can be printed here. This is then preprocess. And then this one must end like that. Yeah, the continuous state is now preprocess. Oops, and we're done with filling, so filled. And then this one is preprocessed. And now these fix me's, let's look into that, because I think it is already taken care of, isn't it? Or isn't it? Create vertex buffers. I don't know, let's just not do it. And then I'll just debug it until I find out that it is missing. And then we'll fix it, because it should not be done here anyway. All that debugging takes a lot of time, but it gives me also insight. Yeah, I think I fixed this as should now, but basically by adding an empty do nothing state, which is not good. But let's get it to work first, and then hopefully maybe someday I can work away this kind of awkwardness. Oops, we're not even crashing anymore. It's just saying that there's no pipeline. Well, yeah, I guess it's time to go to bed again. Although if I go to bed now, I'll just lay awake for hours, which is the case every day and then I get out of bed at 1 PM because I need my sleep anyway. It was kind of pointless to go to bed this early, I have the feeling. But I did get out of bed at 1 PM, that's like 11 hours ago. Yeah, Post Bunny, but you can lay in bed right now listening to me. The worst thing I could do now is to make it possible to stream from my bed. Hold on a moment, I'm going to bed and then we'll continue. Okay. Pipeline not available. Yeah, we also have to talk about the Christmas stream. So during Christmas, I'll do a stream, and then we do something special, not a Vulkan engine. And I have been preparing for it. That's why I have not streaming that as much. Yesterday and today. At the very least, I did get Christmas music, so we can play Christmas music, and then everyone who is going to join has to buy chocolate milk, of course, that they can warm up. So at some point we can all drink coffee, warm chocolate milk. I guess I'll buy a bag of marshmallows as well. And then I think it's a good idea to start a stream at the given time. So now I'm just, randomly, suddenly I start streaming. And people never know if I am streaming or when. But for the Christmas thing, it's pretty important, I think, that those that want to participate, that they are there from the beginning. If you want to be able to follow what we're doing. So I should set a time. What would be a good time to start my Christmas stream? Cocoa milk mix. Yeah, as long as it's chocolate milk, basically, right? Isn't that? Yeah, that's good. Yeah, and milk. Yeah. But okay, what date? I think Sunday is a good date. So Sunday is the first. It's the first Christmas day, isn't it? How do I find that? Excuse me. When is well? Basically, it's Sunday 25. Yeah, we can do it Sunday. So that's 25th. In the evening, in Europe time, evening time. And I think most of my regulars join my stream during those times anyway. So what about 1900? Whoops. 1900 Central Eastern Euro time, or is it CET? Central Europe time, I think. December 24th. See if this works. Oh, I agree with everything you say. 23 and 21, yeah. That's what my clock says as well. So when this clock says 19 on 25th, so that is Sunday in 1 week. And then, yeah, I don't know how I can say the time. It is CAT, currently UTC +1, so I guess I'll just do it in UTC and then everyone has to convert it. So we can do that here, plus sort of poll, Q&A. Yeah, I know Yes or no? I should have added a different different question, I think. What I want to know is if people who want to join anyway, if it's a convenient time, or if they just, you know, would like to 1 hour later or something. I can tell you already what I wanted to do, but maybe I changed my mind. So I've put some time into. Well, basically, what I wanted to do is to try to get up between quotes, prove the Collatz conjecture, which is completely insane, but I think it's just fun. Let me show you what it is. Collatz conjecture. The Collatz conjecture is one of the most famous unsolved problems in mathematics. Paul Eros said about the Collatz conjecture, mathematics may not be ready for such problems. And he offered $500 for a solution. Jeffrey Lagaria stated in 2010 that a Collatz conjecture is an extraordinarily difficult problem, completely out of reach of present-day mathematics. So that seems like a really fun to try to prove. So on Christmas I'm going to try to prove a conjecture that nobody has managed to prove yet. Because it's just too difficult. So I'm going to fail. We know that in advance. But it'd still be funny. Okay, so what is it? The conjecture is that the conjecture asks whether repeating two simple arithmetic operations will eventually transform every positive integer into 1. And that what we do is we start with some integer n. If n is even, the next term is 1/2 of the previous term. So just divide by 2. As long as it's even, you divide by 2. Until you end up with an odd number. And when it is odd, you multiply it by 3 and you add 1. Okay, so here are a few examples. So take, for example, well, not too long. I'll take the 7 here. 7 is odd. 7 times 3, 21. Plus 1, 22. That's even. So divided by 2 is 11. That's the next odd number. And then 11 times 3 is 33. Plus 1 is 34. It's even again. So divided by 2 is 17. 17 times 3 is 51, plus 1 is 52, divided by 2 is 26, divided by 2 is 13. 13 times 3 is 39, plus 1 is 40. 40 divided by is even. 40 divided by 2 is 20, divided by 2 is 10, divided by 2 is 5. 5 times 3 is 15, plus 1 is 16, and then we divide by 2, 8, 4, 2, 1. And then we're at 1. And the conjecture is this, that absolutely any integer will end up in 1 if you do it like this. So odd numbers multiply by 3 and add 1, and even numbers just divide by 2 until it becomes odd. And nobody has ever been able to prove that this is the case. I think they're just stupid. We're going to prove it. Yeah, let's quit. On Christmas. And of course we're going to use C++, right? I mean, I'm not going to do pure math. I'm just going to write interesting C++ programs that will help us with this. I'll do some prep work. So if it's a piece of code that is really boring, then I'll already have it written. Can even show you what I already did. So the binomial, we're going to need a binomial. So I have this code already, and that just calculates the binomial. If anyone doesn't know what a binomial is, I can also do a little test of that code. You see, this is a Pascal's triangle. So 1 plus 1 is 2, 1 plus 2 is 3, 1 plus 3 is 4, but anywhere else is 20 plus 15 is 35. It's like a simple number wall, in fact. I should not close this. Then my mouse stopped working, as usual. So this is so crazy. Something is wrong here. This. Yeah, no, it's just jump to the top and then it doesn't want to go away anymore. Yeah, there we go. Finally. I still think I should stop. It's 11:30, yeah. I'll continue with this tomorrow. And then we'll, well, do the next problem. And the next, and the next, and the next. Good night. Thank you for keeping me company again, peoples. And if you want to be here during Christmas, then have a look at the Collatz conjecture. There are also YouTubes about it. You know, like I'll find one from you. YouTube.com. Search and Collatz conjecture. And then we get music. Yeah, there we are. The simplest math problem no one can solve. So look at this one, for example. Well, this one, or, well, that's not interesting. Proof of the Collatz conjecture. What? It is proven 3 months ago. Ah, fuck me. We're too late. It has already been proven. And instantly, it's no fun anymore. How can it be fun to do something that has already been done? Shit. The great Collatz collab is complete. Oh boy. Yeah, well, there are loads of YouTubes about it, but I'm shocked to see that it is already proven. So then I don't know what to do. I don't think it will be fun to do a problem that is already proven. If you get what I mean. I'm gonna watch this myself. Day 2, 1 year ago. So Terence Tao looked at it. Yeah, he's the rock star of mathematics. And apparently it took him a year. Okay, I would have failed anyway, but it's still, you know, you can do it during Christmas, start to look into it. But, well, most likely I would fail, right? And then, I don't know, man. I don't think it's fun. But it is a beautiful thing because it is so simple. Anyway, look one of these two. This one is 6 years ago, this is even 1 year ago, and it's still about that there is no that no one did solve it. I guess this is a good one. I can make a copy for you. Okay. Go watch that. I might still do it. So I'll just leave it to the people. If people that join say yes, this is a good topic, then we can still do it.